Hi everyone. In the last session, we learned a little bit more about the inverse of a function and also how to find the undefined value of a rational function. So this now will be the last session of the theory behind functions, where we'll be learning the last thing that we need to know for CSEC, um, for CSEC functions, which is called composite function. Right now, sometimes some people may call these functions within functions, and it also makes sense, right? So what a composite function is, composite means made up of more than one or multi, or yeah, actually made up of more than one different functions, right? So suppose that we have an input set, right? And then we have an output set for that input set, and then this output set we want to map these values through another function, right? So let's say we have one function here, one relation here. So the first one we call it f, and the second one we call it g. Now suppose we want to go straight from this function to this one here, right? Which is we are making a complete composite of this function because we are combining these two functions to get one complete function then. Right, so that is what a composite function is a combination of multiple functions to make one function. So what we say for composite functions is if f of x, if f of x and g of x and g of x are functions of x, then, right, so f, now this here, f g of x, right, now this is what you'll normally see it as. Right, now how we read this is we read this as f of g of x. Right? So it means that you are substituting the entire function of g of x within the function of f, as we'll see in some questions. So we say f of g of x is the composite, is a composite function of g in f. Right? So we are applying or we are substituting the function g into the function f. And similarly, you could have g of f of x, right? So this is better explained by doing some example. Right? So let's say, for example, we have f of x is equal to 2x plus 3 and g of x is equal to 5 minus x. All right, so let's say they ask us to find part 1, f of g of x. All right, now how do we find this here? F of g of x. Another way to think about this is you could think about it like this here. I'm gonna write it on the side as we can see it. Right, a little working column here, right? So on the side here, f of g of x, it could be written like this here. F brackets g of x. Now what this means is that you are taking whatever g of x is and you're substituting that into f. So check what happens here. So you work essentially with the second function first. So you substitute the second function, which is 5 minus x. And now you are taking this function and plugging it into f. So wherever it has x in f, you replace it with this entire function. So what we get is 2 into 5 minus x plus 3. Right? Because remember, f of x was 2x. So f of the input is 2 by the input plus 3. But the input of f here is 5 minus x. So you are inputting 5 minus x into f. Yeah. And now to simplify, 2 by 5 is 10x. 2 by 5 is 10, sorry. Minus 2 by x is 2x plus 3. And now 10 plus 3 will give us 13 minus 2x. And this is the composite function f of g of x. Yeah, let's go with part 2 now. Part 2 is g of f of x. How do we do this? So g of f of x. It means that, again, if we just put it to the side here to see it a little bit better, g of f of x means that in the function g, you are substituting the function f of x. So f of x is the input to g in this case here, right? So it will be g of f of x is 2x plus 3. So it means that your input into g is now 2x plus 3. So g is this function, which is 5 minus the input. Yeah, because in this case, remember g of x, this is not inverse. So this is the input, 5 minus the input. And the input in this case is what is inside the brackets, which is 2x plus 3. I know you notice I put the brackets. Now, a lot of people will just do this, right? They will change x to 2x plus 3 and not put the brackets. Whenever you substitute, you need to put the brackets, and let's see why. If I had left out the brackets, I would just get 5 minus 2x plus 3. But the correct thing is, if we look at this, it is 5 minus 2x because this is minus 1 here. And minus by plus will give you a minus 3. And this will give us 5 minus 3 is 2 minus 2x. Now, something to take note of here is that f of g of x is not equal to g of f of x. So, a little side note here, something I need to take note of is note in general, f of g of x is not equal to g of f of x. So what that means is that the composition of functions is not commutative. Right? It means that you can't do them back to front and get the same result. Right now, another thing that you could come across here now, if you just continue with this question here, right, with the same information. Sometimes you might see this f of x, right? Or it may also be written in an x way, right? It may be written like this here. F of x is one way that they might write it, or they could write it as f squared x. Right now, what this is, both of them means the same thing, right? What this is telling you, right? And actually, I'm gonna write it like this. So f squared x, if you ever see this, it means that you are composing f with itself, right? So that means that you are substituting f into itself, f of x. So it will be f of the input into f is itself. So 2x plus 3 is the input, right? And now what you are doing is you look at the function f and your input is 2x plus 3. So it will be 2 into 2x plus 3 and then plus 3. Because remember, f of x is 2 by the input plus 3. But the input into this f is the function itself. Right? And now just expanding it out, you get 2 by 2x is 4x plus 2 by 3 is 6 plus 3, which will give me 4x plus 9. Yeah. And now g is 5 minus x. So if we were to do the same thing for g part 4, suppose they ask us for g squared of x. This means that they want g of x. And again, g of x means what? G of x means this you are substituting g of x into itself. So g of x, if we scroll back up a little bit, g of x is the function 5 minus x. So it's 5 minus the input, but the input is g of x. So 5 minus x, which will give me 5 minus 5 minus 5 minus is a plus x, which will just leave me with x. And 5 minus 5 is 0, 0 plus x is x. Right? And this here is the composition of functions. It is pretty easy, right? Now part 4, they can ask us for something else, right? Part 5, sorry. Another type of question that could fall under this here, they could tell us to find f of g of 2. Right now, they have two ways to do this actually. Right? So f of g of 2. Right? If they ask us to find that, we already have f of g of x. right? So f of g of x is 13 minus 2x, yeah? So I'm going to write that here. From 1, f of g of x is equal to 13 minus 2x, because that's what we had up here, right? So f of g of 2 means in this f of g of x, your input is 2. So this will be, you are just taking 2 and replace it with x. So this will give us 13 minus 2 into 2, which will give us 13 minus 4, which is 9. And that's f of g of 2. Now there's another way to do this here now. To find f of g of 2, right? The first thing you could do is find g of 2. So g of 2, if I recall what g of x is, g of x is 5 minus x. So g of 2 will be equal to 5 minus 2, which is 3. So therefore, f of g of 2 is f of 3, because g of 2 is 3. And now if we find f of 3, the function f of x is 2x plus 3. F of x is equal to 2x plus 3. So we are looking for f of 3. So you take 3 and plug it in here. So you'll get 2 into 3 plus 3, which will give us 6 and 3 is 9. So you end up with the same answer anyway. So you don't need to find the general composition of two functions to find the answer for this. It's up to you to decide and depending on the information that you have. All right. So so this here is how we do composite of a function. All right, so let's do a couple more examples on this here. Let's say, for example, we have, if we are given f of x is equal to x squared and g of x is equal to 2x minus 1 over 3. All right, so let's find part 1. Let's see if we could get this here. So let's say that they ask us again to find f of g of x. So what this means, and a way I like to write it for students is, I like to put the brackets around it. So it means f of g of x. So it means in the function of f, the input is g of x, right? So in the function f, you are taking this whole g and putting it into f, right? So it will be f of this entire function here, which is 2x minus 1, f of 2x minus 1 all over 3. So now what is f? F means that you are taking the input and squaring it. But the input now is this entire function, right? So that will give us 2x minus 1 over 3 all squared. And that's it. Yeah. So this is how we do the composing of our functions, right? If we go with, I'm going to do part 2 across here. So part 2, let's say that they ask us to find g of f of x. So g of f of x means into the function g, you are substituting f of x. So first thing, you change f of x to what it is. F of x is x squared. So now this is the input that goes into g, and g does this to the input, right? So this will give us 2. The input is now x squared minus 1 all over 3. And that's it. Right? So that's the composition of functions. So now what we'll do, we will look at a few past paper questions on functions, answer them, and we could see a fair amount on how we do functions. So let's look at this first one here, which is from January 2009. Right, January 2009. Right, so two functions are defined as follows. Now, remember, this is one way to write, to represent a function, which we did earlier, right? But all this means, if it is you want to look, and you notice they change up the notation here, right? Which is a little bit of a fault with TXE, right? So what we did here, another way to write this, you could rewrite it as f of x is equal to x minus 3. Similar to this one here, you could rewrite it as g of x is equal to x squared minus 1. So for part 1, they ask us to calculate f of 6, which isn't too bad. You just look at f of x and replace x with 6. So again, just to recall what this means, when 6 is the input, they're asking you to find the output, right? And this is the formula to find the output. So it becomes 6 minus 3, which will give us 3. That's why this was only 1 mark. Fairly easy to do. Right? Not even fairly easy, very easy. All right, part 2 now is f inverse of x. Let's do f inverse of x here. So they want us to find the expression for f inverse of x. Remember, you have 4 steps to do that, right? Technically, our first step, or 0th step, as it should always be, is just write the name of the function and the instruction. The next step now is you let y be equal to f of x, right? So what this will give us is wherever it have f of x, you replace it with y, and this is just for simplicity. Y is equal to x minus 3. The third step is interchange x and y. So it means wherever it have x, you put y, and wherever it have y, you write x. So in this here now, we will get x is equal to y minus 3. All right, and now your next step now is make y the subject. Make y the subject. So how do we do that now? We give on this equation, x is equal to y minus 3. Let's just write it back. And to make y the subject, you just add 3 to both sides. And this will give us x plus 3 is equal to y. Or if we write it how we normally are accustomed writing it, y is equal to x plus 3. And our last now is replace y with f inverse of x. And we're done. Therefore, f inverse of x is equal to x plus 3. We're done. And a few easy steps, nothing too bad there. All right, and now part 3. I'm going to do part 3 on top here so we can still see the functions a little bit. All right, we want to show that f of g of 2, oops, apologies. Yeah, f of g of 2 is equal to g of f of g of minus 2, which is 0. So there are 2 ways again we could do this. You could find g of 2, g of minus 2, and substitute them both into f, or you could first find f of g of x. So let's do that. Let's find f of g of x. So what that means again is just taking g of x and substituting it into f, right? So the entirety of g of x goes into f, and f is x minus 3. So this becomes f of x squared minus 1. So it means in f, you are replacing x with x squared minus 1. So it becomes x squared minus 1 minus 3. Yeah, because it's this x is being replaced with what is inside here, which will give us x squared minus 1 minus 3 is minus 4. This is not multiplied by minus 3. This is the contents of this bracket subtracting 3. So they want us to show that this is equal to 0 and that this is also equal to 0. So f of g of 2 is, you replace x with 2. So this gives us 2 squared minus 4. But 2 squared is 4 minus 4. And that's equal to 0. And this one now, f of g of negative 2. F of g of negative 2 is equal to negative 2 squared minus 4. Negative 2 squared is negative 2 by negative 2, which is positive 4 minus 4, which is also equal to 0. So therefore, what we see is that f of g of 2 is equal to 0, but that is also equal to f of g of minus 2. Yeah, so they are both equal to 0. So they are both equal to each other. Now this was technically a proof. So I ended off with one of our proof ending symbols. Yeah, and that was a nice easy question there. Let's do one more question again, one very similar to this one here. I think this was um June 2009. Right, so it's like a June 2009. Right, June 2009. Right, so how do we do this one now? Right, it looks pretty similar to the last one that we did. So given that f of x is 2x minus 5 and g of x is x squared minus 31, calculate the value of the first one, f of negative 2. Remember, whatever you are substituting, put a brackets around it. So you are taking negative 2 and replacing x with negative 2. The input into f is negative 2. So we will get 2 into negative 2 minus 5. 2 brackets negative 2 means multiply. So that's negative 4 minus 5, which will give us negative 9. And that's it. F of negative 2 is equal to negative 9. Pretty easy, nothing too bad there. Now g of f of 1. Again, we have two ways to do this, and I will do both ways with you now. All right, so part 2, method 1. Right? So we could first find g of f of x. So g of f of x. It means into g you are replacing f of x. So it is g of 2x minus 5. And this will give us, you are taking 2x minus 5 and putting it into g. So it becomes 2x minus 5 squared minus 31, because the function g is the input squared minus 31. So the input is 2x minus 5 minus squared minus 31. Right, now that's g of f of x. So they ask us to find g of f of 1. G of f of 1 is equal to 2 into 1 minus 5 squared minus 31, which will give us 2 minus 5 is negative 3 squared minus 31, which will give us 9 minus 31, right? And that wasn't so bad there. Yeah. So if it is, you work this out here, we're supposed to get back the same answer if we do the second method. So 9 minus 31 is negative 22. Now let's try method 2 now. Right? We're supposed to get the same answer. So to find g of f of 1, all we need to do is find first f of 1. So f of 1 is, you take 1 and substitute it into f. So it becomes 2 into 1 minus 5, which will give us 2 minus 5 is negative 3. And now we take f of 1 and put it into g. So therefore, g of f of 1 is g of negative 3. And g of negative 3 means you're taking negative 3 and replacing it with x. So it becomes negative 3 squared minus 31, which is the same steps as we had before. 9 minus 31, which is negative 22. So this second method is a little bit shorter. It all depends on the question that you have. And last one now is f inverse of 3. Right? So now, technically, there are two ways through this one, right? But since we're dealing with f inverse, we will just find the f inverse one time and put it in, right? However, I will actually show you a second method around this one here. So f inverse of 3, so method 1. So this is the method that we know. So method 1. F of x is 2x plus 5. Yeah, 2x minus 5, sorry. All right, so f of x is 2x minus 5. And when we know the steps here now, right, our first step is let y be equal to f of x. So where we have f of x, replace it with y is equal to 2x minus 5. Our next step now is interchange x and y. right? So wherever it have x, you put y. Wherever it have y, you put x. So you will get x is equal to 2y minus 5. The third step is, well, not solve for y, make y the subject. Make y the subject of the formula. So first thing, you have to add 5 to both sides. So you get x plus 5 is equal to 2y. And now to get y by itself, you need to divide both sides by 2 to give us x plus 5 all over 2 is equal to y. Rewriting it a little bit more normally, y is equal to x plus 5 all over 2. And now the last step is you let f inverse of x be equal to y. So therefore, f inverse x is equal to x plus 5 over 2. Now, they are asking us to find f inverse of 1, I believe. Sorry for the f inverse of 3. Right? So therefore, or hence, f inverse of 3 is equal to 3 plus 5 over 2. 3 plus 5 is 8. And 8 over 2 is 4. And that's f inverse of 3. Now, method 2. Right, so method 2, let's break down what this means. F inverse of 3. What this means is that they are asked, remember, when they give you this, they saying that this is the output, 3 is the output, and F inverse means you want to find the input. So they're asking you to find the input when the output is 3. Right? Now, our function f of x, right, is equal to 2x minus 5. Isn't this the output? Yeah. So if this thing here is the output, right, because that gives us how to find the output, they are telling us in this here that the output is 3. So this implies that 2x minus 5 is equal to 3. And now we just have to solve for x, because in this case, x is the input. So if we do the same we did before, you add 5 to both sides, you will get 2x is equal to 3 plus 5, which is 8. So you get 2x is equal to 8. And then lastly, this will give you x is equal to 8 divided by 2, which is 4, which is the same answer here. So the reason why this one will be better for this section, or for this particular question, is because this question was only worth 2 marks. So because it's only worth 2 marks, it didn't need to find f inverse. Right? So this here is f inverse of 3 because it is an input, and you notice you end up with the same answer. So therefore, f inverse of x is equal to 4. F inverse of 3, sorry. Because f inverse is an input. Right? So in this session, which is the last session for functions for CSEC, we have done a couple of past paper questions, and we have explained what is a composite function and how to work with composite functions. Right? And that brings us to the end of our CSEC functions course. So now we have 2 courses under our belts, and I will do other courses in due time. I'm working on a stats course, but that takes some time. Right? So in the comment section on YouTube, you can feel free to ask any questions. Right? If I'm sending this to one of my classes, one of my personal classes, I will send this entire notes document to you as well. So you will have that there to practice at any point. Right? So until the next video in the next series, please keep practicing and feel free to check out the quadratics course if you haven't already. Right. So with that being said, I will see you all in the next video. So until then, stay safe, everybody, and keep practicing.